One of the things we can do with an Eigrp topology like this is possibly summarize routes. And when I say we're going to summarize routes, I mean that we have more than one network, more than one subnet, which we can represent with a single route advertisement. For example, notice that attached to routers R1, R2, R3, R4, we have the networks of 172.16.0.0, .1.0, .2.0, .3.0. We might be able to summarize those into just one advertisement, maybe leaving R5 going over to R6. We also have between R1, 2, 3, and 4, between those routers and R5, we've got the 10.1.1.0/30 network, the .4, .8, and .12 networks. Those might be good candidates to be summarized as well. Let's take a look at some of the characteristics of summarization. One of the reasons we would want to do such a thing is to help keep our routing tables small, so we don't have as many entries. Of course, if we're going to do this, it's going to work best if we consider summarization as we're doing our initial addressing of our subnets. It would be a good idea to assign contiguous network addresses to networks that we might want to summarize together. And something sort of unique with Eigrp is that any of these routers can be configured to do summarization. That's unlike OSPF that we're going to be talking about later. With OSPF, summarization can only be done at what we're going to be calling an area border router or an autonomous system boundary router. But with Eigrp, we can do it on any of these routers. And something else summarization can help us out with is limiting the scope of a query. Remember earlier we were talking about how if a router went active for a network, it would send out one or more queries trying to determine an alternate path to that network. And we saw that those queries could get out of hand in a large network. Well, with summarization, our query is going to stop at a router that has a summary route. And that summary route includes the subnet in the query. We don't propagate beyond the router that has that summary route. But we do need to be careful with summarization. This could cause suboptimal routing. After all, we're using less specific information to make our routing decisions, so we might have suboptimal routing. And what's even worse than suboptimal routing is traffic not even getting to its destination. For example, we might have a situation where we route packets to a summarizing router, and that summarizing router, it doesn't know how to get to the specific subnet to which we're sending that packet, and it drops the packet. As an example, maybe I've got several subnets in the 10 dot address space on one side of my network, and I've got other networks in the 10 dot address space on the other side of my network, and both sides of the network are advertising to me the 10.0.0.0/8 network. Well, which direction do I go in order to get to the 10 dot network? That's an example of how discontiguous networks could cause us problems. But in this example, we're not dealing with that, and let's begin by seeing how we can do some manual summarization. Take a look, if you would, at the 172.16 networks attached to R1, R2, R3, and R4. We notice that they have a lot of commonality. They're contiguous networks. They all begin with 172.16, and then if we focus in on that third octet, in fact, I've taken the values in the third octet and broken those into binary in this table on screen, we see that even in that third octet, there's a lot in common. They have the first 6 bits in that third octet in common. This means that in total, all 4 of those 172.16 networks, they all have the first 22 bits in common. 172.16, then we have 6 zeros in the third octet, and when we're coming up with a network address, remember we set all of the host bits to zeros? That means the last 2 bits in the third octet are zeros. All 8 bits in the fourth octet are going to be zeros. That means that I could advertise all 4 of those networks with just one summary advertisement. And what we're doing is we're drawing a line between the point where everybody has bits in common and where those bits start to differ. And from this, we can determine that we've got the first 16 bits in common from the first 2 octets, and now we have 6 more bits in common from the third octet. That means that I could send a summary advertisement of 172.16.0.0/22. Let's go out to our live topology right now and see how to set that up. Let's begin by taking a look at what IP routes R6 knows about. Let's do a show IP route, and R6 knows about each of the individual subnets in this topology. Notice it knows about all 4 of those Ethernet networks hanging off of routers R1, R2, R3, and R4 It knows about all 4 of the links connecting those R1, R2, R3, R4 routers down to R5. So we see a couple of opportunities to do some summarization. Let's first do some manual summarization. Remember, one of the cool things about Eigrp is that we can do summarization on any router we want. So I'm going to go to router R5 and I want to summarize these 4 networks into one. Like we talked about, we could advertise these as a single summary advertisement of 172.16.0.0/22. Let's do that. Let's go to router R5. And we go into the interface that's going to be sending out the summary advertisement. And in our case, that's going to be interface serial 2/0. Let's say interface serial 2/0. And here's the syntax. We say IP summary-address. Eigrp, we give the autonomous system number, which is 1 in our case. Then we give the prefix that we're going to be advertising. Our prefix is 172.16.0.0. Then we give, not a wildcard mask, we give the subnet mask. We say 255.255. Remember, we have 6 bits in common in the third octet. That means the subnet mask for the third octet is going to have 6 1s and 2 zeros, and that's a 252 in decimal. And we're going to have a 0 for the fourth octet in our subnet mask. That's our summary advertisement. And notice it says this caused a neighbor change, and that's because we have a summary route that we've now configured. Let's see how things look different now from the perspective of router R6. If we go to R6, just a few moments ago, we saw that we could see information for each of these 4 individual subnets. Instead of advertising these 4 individual subnets, now we should be advertising just a summary route. Let's see if that's true. Let's do a show IP route. And now, look at this. We now have the 172.16.0.0/22 subnet that's being advertised. It's a summary route, and it still lets us get to all of those IP addresses. Let's prove that. Let's do a ping to 172.16.0.1. That's the Ethernet segment off of R1. How about 1.1? Let's try 2.1, and finally 3.1. We're able to reach all 4 of those different subnets by using this summary route. Oh, and by the way, if we go back to router R5 and we do a show IP protocols command, it tells us what address summarization we have configured. It says on serial 2/0, we are advertising this summary route. And that was a way to configure manual summarization, but there is a way to do automatic summarization for Eigrp. And that can be a good thing, or it could be a bad thing if we had, as one example, the discontiguous subnets we talked about earlier. But here's the idea behind the auto summary feature. If a router has more than one interface in the up state, and those interfaces belong to different subnets of the same classful network, if we enable auto summary, the router is going to advertise a single classful network. And if you take a look at the links between R1, R2, R3, R4 going into R5, they could all be summarized as the 10 dot network, couldn't they? They all belong to that classful network. So what if we turned on auto summary on R5? Here's how we do that. Let's go into router configuration mode for Eigrp Autonomous System 1, and let's say auto-summary. Now let's go back to R6 and see how things are different. If we go to R6, let's do a show IP route once again. And look at this. Not only have we summarized the 172.16 networks, we've now summarized all of those 10 dot networks. If we scroll up just a bit, we could see that before we saw the individual subnets. There were 4 of them. However, now, thanks to auto summary, we just see a single advertisement for the 10 dot network. And to give you a brief summary of this video, we said that we could reduce the size of our routing table. We could limit the scope of query messages by doing summarization. There's a potential danger there. We talked about suboptimal routing, maybe dropping packets if we have discontiguous networks. But if we design it correctly, this could be a very good thing in our network. And we saw how to do manual summarization, and we pointed out that summarization can be done on any of our routers. It doesn't have to be a special type of router, like OSPF has to use certain routers to do summarization. And besides doing manual summarization, we also saw how to enable the auto summary feature.